We will be starting with the first presentation of the day, and this is Merging Brazil Digital Metrological Artifacts with Blockchain Presentation with Blockchain. The presenter will be John Martina from the Universidade Federal of Santa Catarina, Brasil.
Sí, Diego, muchísimas gracias. Aquí tenemos algunas preguntas para Diego y para Jimmy. Bueno, empezamos con Jimmy.
Jean is a senior lecturer and researcher at LabSec Security Laboratory of the university. He's currently working on authentication protocols for telemedicine environments, on the formalization of security ceremonies, the designs of IoT-tailored security protocols, and blockchain application. Jean is also a visiting lecturer in computer science at the University of Hertfordshire, working mainly as project supervisors for BSc and MSc degrees. Welcome, Jean Martina. Please go ahead with your presentation.
Okay, Rodolfo, thank you very much for the introduction. I'll just put my slides in full presentation mode. I'll be looking to my side because I have another screen, so I can keep an eye on the chat as well as do my presentation. So let me just get that. So I hope you can see my screen now. Is it?
Yes, we can.
Okay, great then. So first of all, I would like to thank you all for the invitation. Okay, it was a pleasure. We've been working with different projects till today, some involving Inmetro, that is our metrology institute here in Brazil. And what I'm trying to bring you here is how to connect a project that Inmetro has today with blockchain in the near future. Okay, and we have everything set in this sense, and it will be probably a very important thing to be doing in the future, this merging between the metrological devices and the artifacts that they generate, and use blockchain to track that. So to give you some context, okay, Inmetro has a project that is being run here with LabSec at Federal University of Santa Catarina that's called Medida Inteligente. It is for an intelligent measurement system for fuel pumps in Brazil. Okay, Brazil has an endemic problem of gas stations messing up with the metrological devices, and having and we end up having problems on when you go anywhere to fill up your car. Okay, because these devices, even though they are certified, they are tampered with by the users, and due to the sheer size of the country and the way how the metrological certification process work, sometimes it's very difficult to catch every single fraud. And there are some research here in Brazil today that tells us that we have like probably 50% of the gas stations in Brazil have some issue when dealing with this sort of metrological devices, and frauds end up happening. So what happened is that Inmetro has now a digital certification for metrology project, that is this one. It ends up being developed as an app that will be in the hands of the citizen trying to fuel their cars. Inmetro for that is using a strategy based on the Brazilian PKI. Okay, so Inmetro became a certification authority within the Brazilian PKI in 2022. And what happens is that Inmetro, with the local players in this market, they're developing a metrological system that will create a digital artifact that is digitally signed for every measurement that is taken. Okay, and that's being actually delivered to the user in this app, and the user can check if the information is correct from that tamper-proof and verified device. And if they don't see that correct, they can report problems. Okay, so it is a security and inspection infrastructure that was built, that is already a reality. Okay, we have already few pumps working with that. We have this app starting to be used. Then comes the question: is there an opportunity on having in Metro going? Starting producing these digital artifacts for measurements, and what we realize is that every metrological device will be able in the future to generate these digitally signed receipts of the measurement, and this is quite interesting, because if we use these receipts, we can track use, okay, and also track variations in calibration in certain conditions. And what we realize is that if we collect most of the measures, or almost all the measures, we can start deriving some byproducts that are not exactly what the metrological artifact, the digitally signed metrological artifact, was designed to provide, but we can start creating derivations. So in this case of fuel pumps, we are targeting having a metrological control on the volume that is being released by the pump. But if we are able to collect all these measurements and with some little information, we can actually check how good or bad is the actual car efficiency certification program that Inmetro also runs. So what we've seen so far is that there is an opportunity when we have these metrological digital artifacts widespread. But then comes some questions. How do we collect them all? How do we organize them all? And how do we process them all? Okay, so one of the suggestions that we have been introducing is the use of blockchains. In a more specific sense, we are thinking using Hyperledger Fabric, okay, because it has a more business-oriented notion and strategy, and also because it can be targeted better for this sort of application. So for those who do not know very well blockchain, the idea is that we have a ledger where everything that is happening is being recorded in there. We use this transaction list to keep history, okay, so we know what happened and when it happened and whom made the change. And it is basically a hash pointer strategy, so every block points to the next and has the integrity of that block. Okay, and talking about Hyperledger Fabric in itself, it has some efficiency tweaks, like what we call word state. That is a database that tells you the latest state of a certain variable or a certain asset that you're tracking within the blockchain. And it is designed also to work in a private and permission way. So we need to authorize people who will be joining the network and people who will be actually using the data on the network. If you need more information, we have like the documentation for Hyperledger Fabric, but the idea here is that the transactions are part of block datas. These block datas are interconnected between themselves, okay? And then we have a hash chain to guarantee integrity of the whole data that is being put in there. Also, the organization of Hyperledger Fabric is slightly different than what one would know when using standard blockchains, okay? Because most of the blockchains, they focus on financial transactions, and then they come with an assumption that makes sense in that scenario. That is the use of pseudo identities, and basically we have that concept of wallets, and that you don't have to identify yourself and so on. And in certain scenarios, like metrology and legal metrology, in this specific case, it is very, very important that all the peers are identified, all the transactions are digitally signed, and that we know for sure who did what. Okay, so in this sense, I think what's important to explain you here is that the organization of the network is slightly different. Okay, we have the concept of organizations. Okay, so an organization is someone that would like to join the network. An organization may play very different roles. Okay, we have also the concept that Hyperledger Fabric allows us to have multiple ledgers. We do not have to have one single ledger. We can also have multiple consortiums. Okay, so you may participate in the network with different peers, with different views of the information. But the most important thing in here is that we do not act into this network, or we do not interact with this blockchain infrastructure with anonymity. We actually do that being identified. And the strategy behind identification in Hyperledger Fabric, it comes from using digital certificates. That attaches very well with the strategy that Inmetro is already using to create identities for each one of the metrological devices that are being put in at first in this fuel pump scenario. Okay, so what's important in here is that Hyperledger Fabric changes this strategy on identity management that is used in blockchains. Okay, and this in here entities are identified solely using X509 certificates or some sort of alias to that whenever you want to provide them some pseudonymity. Okay, so it's mostly by using certificates. These certificates are issued by certification authorities that can be organizationally owned, or in like the case that we are about to propose for you here, using like a countrywide certification authority scheme. Okay, certain different fields in the digital certificates will identify the type of entity, if it is an entity that can hold a copy of the ledger, or if it is an entity that can run an application, can call a contract, and so on. And what we've seen is that using this sort of Hyperledger Fabric, it's very, very interesting when we are doing government subsidized or government-oriented solutions, especially because it does not assume pseudonymity by default. So we do not have to cope with problems that pseudonymity brings us, like having to like a consensus strategy that would be wasteful in resources, okay, like proof of work or proof of stake. And in this sense, we've seen that Hyperledger Fabric is very, very interesting. Also, it is reasonably easy to configure Hyperledger Fabric to accept certificates from different sources and from different origins. So it's basically the whole access infrastructure in whichever entity in the Hyperledger network works like that. You have like a membership service provider, and in there you have the certificates that you trust, either for identity or for connection. And basically what you need to do is to put the right information in the right folder, and then you can put a Hyperledger Fabric to run under certain digital certificate conditions. Okay, so what we have in here is that there are some special fields that needs to be used whenever you want to issue a digital certificate to enable that identity to run in the blockchain. Okay, so if you are doing that with Hyperledger Fabric, either you use this object ID that is 1.2.3.4.5. That's there is a very odd story on why do they use this number. This is not a YANA assigned number. Okay, it's sort of a joke how it ended up in the code. But then you can also identify the entities by organizational unit or common name, or these attributes. And then you can tell if the person can do things as an admin, as a client, as an order, or as a simple peer for running an application. Okay, so it is very important to tell that, because the only change that Inmetro would have to do to make all fuel pumps being able to cast their registries to a blockchain would actually be adding one of these elements into the digital certificates that are being issued. Okay, so if the fuel pumps that already are being certified and having ICP Brazil, that is the Brazilian government PKI digital certificates issued to them, if they bring some of these identifications here, like the using specific OU or object IDs, then that fuel pump, every single metrological artifact that is generated by the metrological device would be blockchain process. You'll be able to process it in a blockchain. So it is a very, very tiny modification on what's already going on. What happens is that there is another caveat whenever we are talking about integrating these digital certificates from the Brazilian PKI to Hyperledger. Okay, because most of the blockchains around the world and most of the implementations, they use NIST-based cryptography. Okay, so basically you'll be using elliptic curves, ECDSA, that is elliptic curve digital signature algorithm, and they will be using curves that are based on NIST specification. And what happens is that in 2012, Brazil banned within the federal government the use of these elliptic curves, okay, because of Snowden's revelation on how maybe some of the elements of on the choices made to create these curves were tweaked by NSA, and that may pose a risk. And what happened is that Brazil never used that. Actually, Brazil uses ECDSA with Brainpool, that is a German curve system, okay, for ECDSA, but we have that ban. So it is very difficult for Brazil to go straight using the digital certificates, just augmenting that that digital certificate with those elements that I just shown. But what happens is that Brazil now uses a new digital signature scheme for elliptic curves that use what we call Edwards curves, and most specifically, Brazil uses ED 25519 and ED 448. And actually, in Metro, when creating their infrastructure within the Brazilian PKI, opted for these Edwards algorithms. They are very good and very efficient. They are so efficient that they are now part of the TLS standard. TLS 1.3 already uses that. So what happened is that here we started developing Hyperledger in itself. The standard code base do not support these digital certificates. To make that possible, we here in LabSec, we produced a pull request. Okay, we made some code changes and we submitted last August to Hyperledger. And basically what we are doing, okay, because our certification authorities cannot use ECDSA or, of course, an RSA doesn't make sense on a blockchain due to its size. We produced Edwards curve support for Hyperledger Fabric, and then we brought that as a pull request, and it's the pull request 3343 if you want to take a look on the discussions. And what we receive now is that it will be native, it will have likely native support in Hyperledger Fabric 3.0. So we actually have all the conditions so far to actually get the digital artifacts that are being produced by the digital the digital metrological devices that are already in place in Metro here in Brazil, and actually attach that to a blockchain. Okay, so this is an example of the digital certificate standard that we are using. Okay, so what I can tell you here is that we are actually, let me see, where's the doesn't show here the key. Oh, we have here the attributes, okay, that we need to put on the certificate, and then we have the elliptic curve that we are using, and that's actually a digital certificate that we produce and that we already try to run a network in a testing scenario here at the Federal University of Santa Catarina. And our proposal then is that for the creation of a blockchain of metrological receipts, okay, the idea is that every single metrological device that is network capable would be able to cast their metrological artifacts into a blockchain. And with that, we'll be able actually to track, use, and possibly calibration, and devise some new strategies for regulators when they are using calibrated devices and connected devices. So going back to fuel pumps, we may use that blockchain to deliver tax avoidance strategies. Okay, if we know everything that is being filled up by a gas station, then we know the revenue and custom systems here, they know how much fuel they are buying. If we can track all the receipts on that blockchain, they would be able to understand if they are actually selling more fuel than they are actually buying, because this is also a tax avoidance problem. Another thing that we also realized that maybe we can do some process with on-chain and off-chain devices to indicate problems with mixtures in fuel. Like here in Brazil, we have a fuel ratio mixture between ethanol and petrol that varies. Sometimes our cars can deal with almost anything, but whenever you're buying a petrol, you should pay something. Whenever you're buying ethanol, you pay a different amount. And what we believe is that once people cannot cheat the system using volume, they probably will start cheating with the mixtures. And we believe that putting all that into a blockchain may allow us to give out indications that there are problems by having metrological artifacts. We can tell problems on other things like the mixtures. That is not a metrological problem. Okay, so that was what I had to bring you. We are now running some experiments with that, but we have basically no idea when this will be actually feasible in here. But that's it. So I try to be quick so that we have space for questions.
Thank you all. Thank you, Sean. I know that you are in organize another event at the same time. If the people would like to make a question, you could put on the chat. Let me see if there is something on the chat to any question. I didn't see no question at time. Well,
yeah, people can raise their hands, open the microphone. Yeah, I can deal with questions in Spanish as well and in Portuguese. Because my event here that I'm organizing is running in Spanish. So
there is a question from on the chat. Does the system require customer participation for the blockchain to track metrological integrity?
Now, as we are conducting with the system as it is, okay, with the app that runs on the customer's phone, yes. But our idea is that we may be able to force the equipment to actually turn every single measurement to the blockchain, okay, and then we can track if the measurement, if there is a missing measurement, we can actually identify and maybe suspend the operation of that specific equipment. So there are some strategies for that. Okay, the blockchain strategy would not have customer participation. What has customer participation is today's system with the app. Okay, so
I have a question. Who will be the nodes in this blockchain for the?
Yeah, In fact, we haven't decided exactly, okay, but the nodes in this case, there may be in Metro, there may be the state parts of the metrological systems. I forgot their names in here.
IPEM,
yeah. Exactly. So every state in Brazil has like an institute for measurements. So they may be nodes that will be collecting data on their geographical reference and then pulling all that into a network. Okay, and with that we may be able to track more precisely some of these things.
You have another question. You have a project with Education Ministry with the certificates, the university certificates. In this case, the nodes are the universities.
Yes. Yes. Yeah. The thing is, what we are trying here is to establish a standard federal government blockchain strategy. Okay. So, for example, metrology would be one of the consortiums of that specific network. Okay, we already have the network running with education, so we actually are dealing with the higher education degree certificates these days in Brazil. They are completely digital, and what we are doing is tracking them using a nationwide blockchain, and the nodes in there are universities. But we already have now in course a new consortium inside the same network that is on health. Okay, so we are tracking now prescriptions and controlled prescriptions for Anvisa, that is our sanitary regulation agency here, and basically what we want to understand is people having digital prescriptions, not using them twice. Okay, because that's if you have like a digital prescription for a controlled drug and you use twice, the second time you're actually dealing some drugs, okay, because you don't have the proper authorization for that. And then Metrological will be just only a new consortium into that people may be able to tap, and then fiscal will be able to tap that and check fiscal, and like oil and gas would be maybe be another consortium that will tap into the fuel pumps to know if there is a mixture problem within fuel. The idea is that making information available will allow other sectors in Brazil to use it.
And another question, if there is no on the chat, what about the confidential of the information? If you are going to put the information on a blockchain, every node could see the information. How could you prevent the property of that information to not be shared to everybody?
Yeah, usually in terms of metrological devices, they do not have like privacy leakage in one single use. Okay, we may have traces that would allow for identification of certain customer behaviors, but it's very difficult to pinpoint a person by looking only to like the fuel pumps registry. I would know that the gas station has a behavior, but then it's a company, it's not a person, so it's not protected by any of these privacy laws. When we do that with prescriptions and with degree certificates, Hyperledger has a strategy of private collections. So what happens is that we track the information on blockchain level, but we exchange the actual data with private information using this private collection strategy that is somewhat like a synchronous object storage strategy that has a level of encryption for you to send information from one node to the other without going through on-chain information. That could be brought to these on the same way.
Okay, anyone who would like to make a question, you could put on the chat. Otherwise, I will thanks. Now there is a question here from Marcelo. There will be integration with the full distributivos companheiro, distribution companies.
In fact, we actually, our idea is that we start tracking fuel pumps. Then it's very likely that the fuel distribution companies, they have another in-metro certified device that will actually fill up the trucks that are distributing the fuel. So if that guy does a digital signature on their metrological interaction, then we can add that to a slightly different contract in the chain and have that as another tracking point for the whole system. So it will depend, okay, how this would work in the future. But the more we collect, the more data we can provide, the more functionality we can provide with that.
As a coordinator of the project inside the Metro, we really don't have at least at now the business model for the project. We have technological model, but we don't have the business model. We are discussing nowadays how to evolve these projects in business, how to financially sustain this project, and there is no model nowadays. As there is no more questions, I would like to thank Mr. Martina and
Rodolfo, thank you very much. I will apologize for everybody, but I'll have to bash off. Like Rodolfo said, I have an event that is running today in here, and I would like to thank you again for the invitation. If anyone is interested on that and would like to talk more about that, I'm putting my email on the chat. Okay, so please write me. I'll be very happy to explain and show you some of the experiments that we ran so far with that. Okay, so thanks a lot.
Thank you.